Hello, students, and welcome to the 53rd lecture on particle physics. And in the last lecture, we were discussing about how to write the Baryon wave function in the quark model. And what I had told you that the total wave function for the baryons that will consist of the wave function which will take care of the localization of the quarks in space, then the another wave function that will take care of the flavors of quarks, that means we are talking about isotopic spin. The third wave function that will have the spin of the quarks because all of them are spin half objects, and the fourth one is the color wave function. What I have told you that the baryonic wave function has to be completely antisymmetric as these are fermions, and color wave function by construction is antisymmetric. Therefore, the important point is that this total wave function has to be symmetric. Now, again, where these quarks are located, that is always symmetric, because whether it is Q1 at R1, Q2 at R2 and Q3 or at R3, or Q3 at R1 and Q2 at R3, that is immaterial, and therefore this is always symmetric. Now if this is symmetric, then these two guys together or even individually, they have to be either both of them symmetric or both of them anti-symmetric, and that means together these two, they have to be symmetric to make the total wave function anti-symmetric. And what we were discussing in the last class, that if we are considering a system of three objects in SU2, why SU2? Because we want to talk only about U and D quarks. And the other point that is that when we are talking about a spin and all of them are quarks, then a spin of these objects which are spin half particles, whether it is U or D or strange, they are also in SU2 representation. Therefore, the algebra which we are developing for the flavors in the isotopic spin space will also hold good when we will try to write the wave function for the baryons to describe the spin of the baryon in terms of the spin of the quarks. Therefore, first we are starting with a simple case, and what I am telling you that all of the time we have U and D quarks in the three states. Now what we have seen on the last turn, that if we have U and D quarks in the two states, then the formation that we can have is 1 plus 1 or 1 0 or 1 minus 1 or 0 0, these possible four isotopic spin states. Now we have to add a third state. That third state can be either a U quark or a D quark state. If that is a U quark state, then that means I am representing it by half plus half. And if it is a D quark state, then I have to represent it by half minus half. Therefore, remember it correctly that we are going to combine 1 plus 1 with half plus half, or 1 plus 1 with half minus half, or 1 0 with half plus half, or 1 0 with half minus half, etc. Now if you see, if I am talking about a guy which has isotopic spin 1 and whose projection is plus 1, now I am adding a third fellow whose projection is plus half, and this plus half we are getting from isospin half, because what I have told you that this will be a U quark. Now if you recall the wave function, then this plus 1 and plus half can only, because the projections are algebraically added, this can give me, there is only one option, this will give me plus 3 by 2. While 1 and half can give me 1 and half can give me the result like 1 minus half to 1 plus half, and that is half and 3 half. But we know that the projection of half cannot be plus 3 by 2. It is only the projection of 3 by 2 which has got 4 possible projections: plus 3 by 2, plus half, and minus 3 by 2. Therefore, 3 by 2 has 4 possible projections: plus 3 by 2, plus half, minus 3 by 2. This difference is 1, this difference is 1, and this difference is 1. As we know that in angular momentum, the change is by 1 unit. While if we talk about this guy half, then it has 2 possible projection: plus half and minus half. Therefore, with half we have half plus half and half minus half states, while with 3 by 2 we have 3 by 2 plus 3 by 2, 3 by 2 plus half, 3 by 2 minus half, and 3 by 2 minus 3 by 2. Then there is another important concept that one has to keep in mind, that when we are saying that this 1 and half, we should never put any sign before it, because J1, J2, J3, whatever we talk about, or S1, S2, S3, or L1, L2, L3, or isotopic spin 1, isotopic spin 2, isotopic spin 3, they can be 0, half, 1, 3 by 2, 2, etc. But they can never carry any sign. It is the projection which carries sign. That will have plus half or minus half, plus 3 by 2 or minus 3 by 2, or plus 5 by 2, or plus 1 or minus 1, or plus 2 or minus 2. Therefore, it is the M1 and M2 that carry sign, and the J, S, L or isotopic spin, they never carry any sign. This we have to keep in mind. And then we have to keep in mind that if I have a J, then its projection M cannot exceed the mod of J. That means if it is 3 by 2, then M cannot be plus 5 by 2 or minus 5 by 2. If J is 3, then M cannot be plus 4 or minus 4. It has to be less than or equal to mod of J. Okay, that we have to keep in mind while talking about the angular momentum or isotopic spin and their projections. Therefore, because what I had told you, that isotopic spin algebra was developed in parallel to the spin algebra or angular momentum algebra. Therefore, all the rules that we follow in the case of angular momentum, the same rule is applied in the case of isotopic spin. Therefore, what I am telling you, that when you are combining 1 plus 1 with half plus half, then plus 1 plus half will give you plus 3 by 2, and 1 and half can give you both half and 3 by 2. Therefore, let me write something like this, which is generally not given in the books, but just for the completeness sake, what I am saying, that 1 is plus 1, half is plus half, plus 1 plus half is giving me plus 3 by 2. This is 1, this is 1 plus 1, and then, or since we have combined these two objects, the final is J1. That means we have J1 M1, J2 M2, and then we are talking about Jm. Therefore, J1 M1, J2 M2, Jm. Now, what I am telling you, that this Jm is here half plus 3 by 2, and then plus 1 half 3 by 2, because 1 and half will also give me 1 plus half 3 by 2. This is plus 1 plus half plus 3 by 2, and then we have 3 by 2 plus 3 by 2. What I am telling you, that m cannot exceed mod of j. Therefore, this is impossible. The only possibility is this guy, and therefore this is what I have written in equation 23, that when 1 plus 1 is combining with half plus half, the state that we are getting is 3 by 2 plus 3 by 2. Therefore, notice 1 J1, whose projection is M1, J2, whose projection is M2. Therefore, this is J1, this is M1, this is J2, this is M2, this is J, this is M, this is J, this is M. If you look at the Clebsch-Gordan table, again, you will find that this value is 1. And therefore, we are getting a 3 by 2 plus 3 by 2 state. And remember, what is this 3 by 2 plus 3 by 2? A state which has isotopic spin 3 by 2 and whose projection is plus 3 by 2. This state is only a delta plus plus particle, because delta exists in 4 states: delta plus plus, delta 0, and delta minus. Therefore, this is quartet of states, and to describe quartet of states using isospin, we define for them, for 4 states, I is equal to 3 by 2, and we assign maximum projection to the highest charge state. Therefore, I3 for highest charge state will be 3 by 2, the projection will be plus 3 by 2, and this guy will be 3 by 2 minus 3 by 2, while delta plus will be 3 by 2 plus half, and delta 0 will be 3 by 2 minus half. Therefore, you see, from plus 3 by 2 we are going to plus half, a change by 1 unit, plus half to minus half, again a change by 1 unit. Therefore, I is 3 by 2. You notice everywhere I am writing I equal to 3 by 2. But the possible projections are plus 3 by 2, plus half, minus half, and minus 3 by 2. Therefore, when we are talking about the right hand side, the first term is the Clebsch-Gordan coefficient, which is 1, and then the second term is representing a delta plus plus state. Therefore, this is the flavor state with delta plus plus. And what is 1 plus 1? You remember the last lecture, this is u in state 1, u in state 2, that is 1 plus 1, and then this is half plus half, this is u in state 3. Therefore, delta plus plus, all of them are u quarks in the state 1, u quark in state 2, as well as u quark in the state 3. And then if I interchange the position of these 3 states by rotating, see, I am on a cycle, these are the 3 states and I have been given 3 quarks, all of them are u quarks. No matter whether I am putting this here or this, these are identical particles, and therefore if they are carrying colors red, blue and green, since the total outcome has to be color singlet, therefore whether I am placing this red here, blue here, green here, or blue here, green here and there red, that is immaterial, and therefore the wave function is completely symmetric. Therefore, the position of u is hardly which u is hardly matters here. Therefore, I am writing in as a superscript s. Mind it, this I am writing because what I have told you, that spatial wave function by construction or is symmetric, color wave function by construction is anti-symmetric. Then we are left with two, spin wave function and isotopic spin wave function. What we are noticing that the isotopic spin wave function for delta plus plus is completely symmetric. Now remember, delta is also a fermion. This will be also described by Fermi-Dirac statistics, where the wave functions have to be anti-symmetric. Color part will give me anti-symmetric. Space part is symmetric. Now we are left with two, spin part and isotopic spin part. If we are finding that isotopic spin part is symmetric, then we are left with only one choice for the spin part, that has to be also symmetric. Then three symmetric from space part, from spin part, from isotopic spin part. All three will together will give me symmetric state. And then we have anti-symmetry from the color. Then these four will give me an total anti-symmetric state, such that we will be able to get a wave function for the delta plus plus, which will be anti-symmetric, as this is a fermion. Therefore, for a 3 by 2 plus 3 by 2 isotopic spin state, for a 3-quark system, there is only one possibility, and that is all three of them are U quarks. Similarly, before going ahead, if I talk about delta minus, then what do you know about delta minus? That delta minus, I have written, this is 3 by 2 minus 3 by 2 is the delta minus state. Now, for the 2 quarks, the states that we have obtained, they are 1 plus 1, 1 0, 1 minus 1 and 0 0. Now, if I want to get 3 by 2 and minus 3 by 2, how do we get it? See, these are the four possibilities. Now I want to get 3 by 2 minus 3 by 2, and we know that projections are only algebraically added. Therefore, my wish or my desire is to get a 3 by 2 minus 3 by 2 state. This I can obtain only by 1 minus 1, half minus half, because minus 1 and minus half will algebraically, when they will get added up, we will give minus 3 by 2, and this we are getting from 1 minus 1, half minus half. 1 minus 1, we know that these represents, in both these states you have d quarks, and this half minus half is again in the third state you have d quark. This is Klebsch-Gordon 1, and this is, we are representing a 3 by 2 minus 3 by 2 state, and this is nothing but delta minus. Therefore, for the isotopic spin wave function for delta minus, it is nothing but d1, d2, d quark in state 1, d quark in state 2, as well as d quark in state 3. And that means, again here, if you notice, if you are going to ride on a bicycle, then no matter where we are placing these d quarks, that is immaterial, and therefore even side delta minus for the flavors, because isotopic spin denotes the flavors of the quarks, that will be purely symmetric. And if this is symmetric, then the choice for the spin wave function, that it will also be symmetric. Now, the other important point in this case is that we have done with the two cases where we combined 1 plus 1, 2 objects with a third object. That third object was half plus half, or 1 minus 1 with the third object, and that object was 1 minus half. But there could be 1 plus 1 combining with half minus half. Now you notice we have plus 1, I am talking about to combine with half minus half. When plus 1 will combine with half minus half, what we will get, because projections are algebraically added, we will get plus half. This will always, the projection will always carry sign. Plus half or minus half or plus 3 by 2 or minus 3 by 2 or plus 1 or minus 1. While 1 and half, when they will combine, they can combine to give me 1 minus half to 1 plus half in step of 1. That means this is half, and this is 3 by 2. Now if I want to get the projection plus half, this plus half I can get from half, as well as plus half I can get from 3 by 2. Therefore, when I am combining 1 plus 1 with half minus half, we have two terms. Similarly, when I will combine 1 0 with half plus half, 0 plus half will give me plus half, and 1 and half can give me 3 by 2 as well as half, and both of them can have possible projection as plus half. Similarly, if we talk about 1 minus 1 with half plus half, then minus 1 plus half can give me minus half. Now 1 and half can give me 3 by 2 and half. Now 3 by 2 can also have a projection minus half, because it has 4 possible projections, and half can also have projection minus half. Therefore, when we are combining 1 plus 1 with half minus half, when combining 1 0 with half plus half, and 1 0 with half minus half, and 1 minus 1 with half plus half, we are saying that 3 by 2 state as well as 1 by 2 state, they are giving us plus half here, plus half here, minus half here, minus half here. But at the same time, if we put here half minus half, then minus 3 by 2 can only be obtained by I is equal to 3 by 2. And here if I put half plus half with 1 plus 1, then plus 1 plus half can give me only plus 3 by 2. Therefore, these two, half minus half, 1 minus 1 with half minus half, this case and this case are entirely independent. One is representing psi delta plus plus, another is representing as psi delta minus. And then we have here 4 possibilities. 3 by 2 that can give me plus half, or half that can give me plus half, or 3 by 2 that can give me minus half, and half that can give me also minus half. Then we have discussed these cases. Then we are left with the last combination. If you look at it, 0 0, and now this 0 0 I want to combine with either half plus half state or half minus half state. If you combine 0 0 with half plus half state, as projections are algebraically added, 0 with plus half can only give you plus half, and 0 with minus half can only give you minus half. Therefore, I am talking about this 0 0. This is combining with half plus half state, or 0 0 combining with half minus half state. What I am telling you, that 0 plus half can give you only plus half, and 0 half can give you half only. Therefore, here you have only possibility a half plus half state. Here, because of this guy, 0 combining with half cannot give you 3 by 2. Similarly, here 0 combining with half will not give you 3 by 2. Therefore, like in the first case, 1 plus 1 and half plus half, and 1 minus 1 and half minus half, here we have 0 0 half plus half can give me only half plus half, and 0 0 half minus half can give me half minus half state. Therefore, we have to keep that in mind before we proceed ahead. Therefore, we have dealt with 1 minus 1 with half minus half, and this is we are getting a delta minus flavor wave function, because what I am telling you, for the isotopic spin, the wave function that we are getting here for the delta minus is that in every state you have a d quark, and then what permutation that you are talking about, that hardly matters. Therefore, this is a symmetric state. Now we are considering the other possibilities. 1 plus 1 is combining with half minus half. Remember, we had 1 plus 1, 1 0, 1 minus 1 and 0 0 from two objects. We are combining the third object, and this we have dealt. Now we are 1 plus 1 combining with half minus half. Therefore, what I have told you, that plus 1 and minus half will give you plus half. But this plus half you can get from 3 by 2, as well as this plus half you can get from half. Therefore, 1 plus 1 half minus half is giving you 3 by 2 plus half. You are forming a 3 by 2 plus half state. And then this is can also get from this half state. Therefore, 1 half is giving you half, and this half can have a projection plus half. Therefore, you are getting a half plus half state. This is representing a delta plus state, and this is for three objects, three quarks combining to give you a baryon. This is the representation for the baryon, half plus half, which is made up of non-strange quarks, U or D. Therefore, you have three states. In all three, you have either U or D, and this is nothing but a proton. This is a Clebsch-Gordon coefficient, which I am representing it by C1, and this is a Clebsch-Gordon coefficient, which I am representing it by C2. Therefore, 1 plus 1 is combining with half minus half is giving me Clebsch-Gordon times, that is a constant, that is a real number. That is why I am writing it by some constant, C1 times psi delta plus C2 times psi proton. Now, the other possibility that we can have, that we can get 3 by 2 plus half and half plus half also from when we will combine 1 0 with half plus half. You see, when I will combine 1 0 with half plus half, this will give me, first I will write 0 here, plus half here, and also I will write 0 here and plus half here. You see, this is 1, this is 0. Sorry. This is 1, this is 0, this is half, this is plus half. This is 1, this is 0, this is half, this is plus half. You see, 0 plus half is plus half, 0 plus half is plus half, everything is fine. But this plus half we can obtain from 3 by 2, and this plus half we can obtain by plus half. Therefore, we have 3 by 2 plus half, which is representing a delta plus, and 3 by half plus half, which is representing a proton. Therefore, here what is this? 1 0, 1 0 for the two objects. If you remember, this is 1 by root 2 u1 d2 plus d1 u2. This is 1 0, and half plus half is the u quark in state 3. Therefore, you are getting 3 quarks, and all of them are non-strange quarks. And what you are finding out from the left hand side is that this is 1 by root 2 u1 d2 plus d1 u2, and then this guy sitting outside is u3. But here again you are getting a Clebsch-Gordon C3, and this is a delta plus flavor wave function, and this is C4, a proton wave function. Therefore, you are getting two equations where you know C1, C2, C3 and C4, they are real numbers, they are tabulated as Krebs-Gordon coefficients. Therefore, they are not unknown, they are completely known. Then you know the left hand side. What you don't know is psi delta plus and psi proton. Therefore, you have two equations and you have two unknowns. Therefore, we are writing this as two equations and two unknowns. C1, C2, C3 and C4 we have tabulated here. You see, we are combining 1, 0 with half plus half. You see, when you combine them and solve them, that we will do tomorrow again. Let's stop here. We will talk about the flavor wave function for delta plus and the flavor wave function for the proton, and then similarly we shall talk about the flavor wave function for delta 0 and the flavor wave function for the neutron. Thank you very much.